In the previous section, we were finding the area of rectangles, which is actually pretty easy to do. You've probably been finding areas of rectangles since you were in elementary school. Base times height, not too bad. But in the next section, in 6.2, we want to talk about finding the area under something called the normal curve. And this is a picture of a normal curve. And the gray shaded area is what we would like to find the area of. So how do you find the area of this irregular shape? It's not a rectangle. It's not a triangle. It's not a circle or a square or a rhombus or a trapezoid. It's not any of the standard shapes that we're used to finding the area of. And so how in the world are we going to find the area of this normal distribution? Well, first, before we get into finding the area of a normal distribution, let's talk about exactly what is a normal distribution. So a normal distribution is bell-shaped, it's unimodal, and it's symmetric. So these are all very important characteristics of a normal distribution. There are also two very important factors in a normal distribution: the mean, which we're going to call mu, and the standard deviation, which is sigma. And so we have mean and the standard deviation. And here are two normal curves. Both of them have means at 100. So you can see the first one has a mean at 100 and the second one has a mean at 100. What's different between the two is their standard deviation. So if you take a look at the first curve, you'll notice that it has a standard deviation of 5, which means its data is clumped together. Remember our conversations about standard deviation and how it's a measure of the clumpiness of a data set? And so standard deviation of 5 means that the data is clumped together. And if you wanted to be numerical about this, you could say that one standard deviation would go up to 105 and one standard deviation below would be 95, okay? In the second graph, we have a standard deviation of 10. And again, to be numerical, that means one standard deviation above would go to 110, one standard deviation below would go to 90. So these would be the locations of one standard deviation above and below, where on the other curve, they're going to be located here and here. And so what happens with standard deviation is it changes the shape of the curve. If you have a low standard deviation, a low deviation, that means that your curve is going to be tall and narrow. On the other hand, if you have a large standard deviation, if there's a lot of deviation in your data, your curve is going to be spread out over a larger region. And so that means your curve is going to be short and wide. It's almost like someone applied pressure to the top of this pile of sand and it just kind of smushed down, right? Like you push down on top of it and the sand smushed out. Okay, that's what standard deviation sort of controls, is the height and the width of your graph. So another thing that we can say about the normal curve, as with all probability distributions, the area under the entire curve. So this entire area, this area is equal to 1. And this area under this distribution, despite it looking differently, this area is also equal to 1. So because you have to maintain an area of 1, as you change the standard deviation, the graph has to get smushed out or pulled up. So all normal distributions have an area of 1. Here's something else. This midpoint, this mean, is a line of symmetry. And this area above the mean is 0.5, and this area below the mean is also 0.5. So what are some other important characteristics of a normal curve? Well, these are the things we've already discussed. It has a mean, which is the highest point, and here's the mean right there. It also has these things called inflection points, and inflection points are located one standard deviation above and one standard deviation below the mean. And these are the points where the curve transitions from a valley to a hill. So here you can think like if you're driving up the valley, and then you finally get to the inflection point, and now you're on part of the hill. And then you travel over the hill and you get here, and now you transition back into a valley. So these are called inflection points, and they are located exactly one standard deviation above and below the mean. A couple things that we've already talked about. The distance from the mean to the inflection point is one standard deviation. The area under the entire curve is exactly one, and the area under below the mean or above the mean is 0.5 or 50%. And so once again, this area, if we use the mean as a line of symmetry, so this area equals 0.50. 50% of the area is above the mean, 50% of the area is below the mean. And what the empirical rule says is that if you have a normal distribution, and this only works for a normal distribution, one standard deviation above and below the mean contains 68% of the data. Two standard deviations above and below the mean, which would be this region here, contains 95% of the data. And three standard deviations above and below the mean contains 99.7% of the data or the probabilities. And so this is called the empirical rule, and it helps give us additional areas. For example, if you know that this area, the area of one standard deviation above and below the mean, if you know that this area is equal to 68%, then you know that half of that area has to be 34% because it's half of the 68. Again, playing on that idea of symmetry. This is the equation of a normal distribution. So if you were to take your TI 84 Silver Edition and plug this equation in, you would get the curve of the normal distribution. So what are the important variables in this curve? Well, there's a mean, the mean of your data set, which is located right here. There's also a standard deviation, which is located here and here. So the mean and the standard deviation of a data set will either be provided for you, or it's actually pretty easy for you to calculate. We did these calculations way back in like chapter 4. Remember where we take a data set and we'd say find the mean, and you'd copy and paste it into Google Sheets and you'd use equals average, or we'd say find the standard deviation and you'd copy and paste the data set into Google Sheets and use equals STDEV. These are those exact same numbers. So they determine the shape of the normal distribution. Some other numbers that you probably recognize, there's a pi in there, there's an e in there, there's a 2, there's a fraction, there's a square root, there's an exponent, there's all kinds of stuff that go into this formula. Now, the good news is you will never have to plug numbers into this formula. You're never going to have to, for example, find f of 2. So take the number 2 and plug it into this formula and calculate a value. You'll never have to do that. And so that leads us back to where we were before about finding the area between these 2 points. And that's what we're going to talk about in the next section, 6.3.